Hello, this is Maria from mathmammoth.com. In this lesson, we're going to continue studying the rate of change and linear functions. Susan went for a jog, and the table shows the distance she has covered as a function of time, and then we have a graph. So, for example, at 20 minutes, she has jogged 2 miles. At 30 minutes, half an hour, she has jogged 3 miles. Then at 1 hour, she has jogged 4.5 miles, and so on. My first question is this a linear function? And we might also check, is it even a function? It is a function because for each input here, there's exactly one output. And also, this graph has not only the dots for these values here in the table, it is a line drawn between the dots. But for each input number, no matter what I choose here, let's say I chose 7 minutes or 7.5 minutes or something, I would find exactly one output, exactly one distance for each time. So it is a function. Is it a linear function? We had a definition in our last lesson that if the points fall on a line, it's a linear function. In this case, well, it looks like there's a line and another line, but it is not overall a linear function because these points do not fall on a single line. Now let's look more carefully at the rate of change. Actually, I wrote here rates of change because there's two. At first, Susan is jogging like this at a certain speed, and then we have these dark red dots, and her speed actually changes, or the rate of change of the function changes. So let's look at this first part of the graph, this line, this portion. And what is the rate of change here? We can choose any 2 points here. If I take the first one and the last one, and I look at the difference in the outputs, this here, it is from 3 miles to 0 miles, 3 miles. And this difference here is 30 minutes. So it is therefore 3 miles per 30 minutes. That's the rate of change for that portion. This simplifies to 1 mile per 10 minutes, which would be 6 miles per 60 minutes, or 6 miles per hour. And then the other portion, let's look at that. Over here, what is her speed, or what is the rate of change of this function? Here, she's at 5 miles at 70 minutes, and at 60 minutes, she's at 4.5 miles. So over here, this distance was half a mile, and this time period was 10 minutes. So half a mile per 10 minutes. And if we convert this into miles per hour, 10 minutes needs to change to 60 minutes 6 times. So 6 times half is 3. So 3 miles per hour. Exactly half the speed as before. So at first she jogged at the speed of 6 miles per hour for half an hour. And then she slowed down and only jogged at the speed of 3 miles per hour for the rest of her jogging for these 40 minutes. From this, I want to give you another definition for a linear function. A function is linear if it has the same rate of change all the time. If its rate of change does not change, then it is a linear function. So this one was not a linear function. The rate of change did change. Here's another example. Is this a linear function? That's an easy question, I guess. It is not, definitely not. Those points do not fall on a line, on a single line. We can look at the rate of change in sections now, because it does have linear sections here. At first, this portion here is linear. Then over here, it is linear for this little segment. And then again here. We have distance and time. And so our rate of change will need to include those units. What is the rate of change in this first portion? Let's say from 0 to 1 second. We check how the outputs change during that time. The output here is 50 meters. At 1 second, it is 40 meters. Okay? So the difference is negative 10 meters. And the time was 1 second. Negative 10 meters per second. So this is again a speed. Maybe something is traveling. If the speed is negative, they're going backwards. Now let's check the rate of change from 2 to 4 seconds. What's that? From 2 to 4 seconds. Actually, from 2 to 3 seconds, we can see that this thing is not moving at all. The distance is not changing. But from 2 to 4 seconds, we would look at those two dots, and the distance changes by, okay, it is here, 35, here, maybe 32.5. So the distance changed by 2.5 meters. And the time was from 4 to 2 seconds, or from 2 to 4, 2 seconds. This is minus 1.25 meters per second. So you can calculate the rate of change between any 2 points, and we got this kind of number. In reality, there is no movement here, and then from 3.5 seconds onward, there is a certain rate of change, which is not going to be equal to this number. But technically, it can be calculated between any 2 points. Then lastly, what is the rate of change from this point here through here? It is the same rate of change through this segment here. So I could calculate it between, let's say, this dot and this dot. Doesn't matter. From 4 to 5 seconds, it's just a 1 second interval. Or I see something even easier. Let's take this dot and this dot. So we have 30 meters and then 25 meters. From 30 to 25 meters, that's a negative change, negative 5 meters over 1 second. So the speed is 5 meters per second, but backwards. This thing is not progressing onward in there. Maybe it is some kind of a track. They are coming towards the 0 line from further onward. Okay, our last question for today. Is this a linear function? Why or why not? Here we have a list of ordered pairs. And remember, a function can be given as a list of ordered pairs. If I look at these differences here, I see a pattern here in the outputs. They go by 4s. 4 and 4 more, 4 more. Okay? And the x values, the inputs, are 2 more, 2 more, 2 more every time. So in this section, at least, the function is linear. If we go backwards towards the negatives, this pattern of 4 more or 4 less does not work there. But the x values are still going by 2s. So there's a pattern in the inputs. Every time, 2 more, but this does not obey the same kind of pattern of 4 more every time. So what does that mean for the rate of change? It means that the rate of change will not be the same here as here. If I calculate the rate of change here, yes, I will get the same number every time. For example, if I take these 2 points, the outputs changed by 4, increase, and the inputs changed by 2. So the rate of change is exactly 2. But over here the outputs are changing, they are increasing by 20. And inputs increased by 2. So the rate of change was 10 between those 2 points. But it would be even different if I took, let's say, this one and this one. Here the rate of change is, okay, the outputs change by 100 and the inputs change by 10. Oh, I was wrong. It is still 10. Okay. But overall, the function is not linear. Let's take one more. This and this. The outputs, the y values increase by 16 and the x's increase by 4. So the rate of change is 4. So we're getting all kinds of different numbers for the rate of change. Definitely not a linear function. Okay, we're all done with this lesson. I hope it was helpful.